Alright, lab 2 for week 3 here. Like I said, we're just doing the 5 basic labs this week. I'm going to ask you some kind of harder questions about these labs. So, lab 2 here, like I said, I went ahead and calibrated up for a 1-inch range on steel. Just kind of verifying the calibration there. 1 inch, 3/4 inch. Let me turn it around here a little bit so you can see it. And then 1/2 inch. So we're pretty much right where we need to be. So let's zoom in a little bit here. Doesn't have to be a lot. Just enough to kind of make sure. There's 1 inch. There we go. Alright, so you can see that okay. Just check a couple thicknesses here. Just basic stuff. Got a block over here. Let's get this out of the way. That out of the way. Jump over here. Bring this block in. Okay. Thicker than our range, which is fine. Alright. Give it a little gain. Let's roll this range out just a little bit. We're on 1 inch. Let's take our range out to 4 inches. That'll work. There's our thickness, 3 inches. Alright, there we go. So you can see that little signal spiking up right there. Question here. If I'm peaking this signal up, if I were to use a DAC, what would that DAC do for me using this block? Okay, you can see here that I've got holes drilled all the way. Okay, holes drilled down here. So all these holes are the same size, so if I were going to set up a DAC curve, what can I do with this block to set that curve up? Okay, that's question 1 there. Just looking at that. Alright, so if we've got that, what would a lamination look like? Okay, so really a lamination in a piece like this and a block like this over here could be very easily simulated by this hole right here. Okay, whoops, knock you around a little bit. So if I move this guy over here in front of, like that, bottom right side of the screen there. Let's go to about a 2-ish inch range. So there's our thickness. So we want to bring our range down to that thickness. Alright. So we can tell how thick our range is, or how thick our piece is. So by doing that, it's 1.7 inches thick. Okay, pretty close anyway. So what's a lamination signal going to look like? Basically, it's going to be a signal that pretty much burns up the back wall pulse, okay, and then gives us a signal in the center. So lamination. The question is, what is a lamination? And how could we use it or not use it in the application of making steel? Okay? So, should have seen that. If you've been with us since visual, you should have seen that in visual. But if not, what is that lamination? How is it going to affect our parts? And what can we do about either getting it out of there or doing something with it? Anyway, so a little bit on compressional beam. It's all the same. We could go through it over and over again, which is a good thing. But really, it's all the same, so there's not a need to just keep going through it and going through it and going through it. But anyway, depth of defects is really pretty simple. Okay, so we've been using our gates a lot. Anyway, so I'm just going to take that gate and move it over to let it tell me what the depth of that hole is. Shows us here. Let's go over to, just lost it. There it is. we go. Okay. So there's 90. Well, I guess that's not right. Probe angle 0. Thickness. .7. Go home. Sound path distance 0.728. That's the depth of that hole. Okay? We know that because if we go over here, take our gate and stretch our gate out, it's going to tell us 1.7 deep. Got a defect halfway through it. Got another defect about a quarter of a way through it. Anyway, a little bit about gates there. We can move it over a little bit. We're not quite catching that first bit of that signal. So that brought it down to 0.324. Anyway, a little bit about gates. Next one will be through transmission.